Oh, I want a jingle with some animation. That would be sweet. We'll have to do with what we have. I built something new. I built a binary watch. This is the peak of nerdiness level to have in your home. Say your friends are not quite sure just how nerdy you are. Throw this in their face and they will leave you alone. They will definitely understand this person is a total nerd. Or if you have a problem with your friends being able to tell the time way too easily when they're in your house, this is your answer. If you're familiar with the binary system, you have the hours here to the left. In the middle you have minutes, and you have seconds all the way over to the right here. The seconds refresh every, well, second. This is constructed off of a few NeoPixel strips. The case, that looks so professional, I made it myself. It's a 3D printed case. It's a two-piece case with a kind of an enclosure printed in black PLA, and the front here is in white PLA. It's thin enough so that it lets through enough light so that you can tell what the pixels say. All of this is driven by a Raspberry Pi, and on that, what is actually controlling the NeoPixels and stuff is a very simple Python script. Anyway, I'm gonna show you how I made it, but first, if you're not familiar with how the binary number system works, I'm gonna try to explain that. I'm sure there are hundreds of thousands, probably not more than 100,000, but still there's a lot of videos on YouTube already explaining how the binary number system works, and I'm sure they all do a very good job, and probably a much better job than I will, but I will at least try. So bear with me through this, I hope, good explanation of the binary number system. If it's not, then I'm sorry, and I suggest you go check out another video later after this video that explains the binary number system, but let's give it a try. Alright, so let's take a regular number that you're very familiar with. It's a base 10 number. So let's take 197. And each position here is worth 10 times more than the previous position, starting from the rightmost number, starting on the value 1. The second number in a base 10 number like this one is worth 10 times more than the first one, so this is worth 10, and lastly here we have this value that is worth 100. We could do some simple just multiplication here to kind of calculate this number from itself. It's stupid, but you'll see. 100 times 1 is 100, plus 10 times 9 equals 90, plus 1 times 7 equals 7, and the sum of these numbers are, of course, 197. So let's look at an example from a binary number, a base 2. Say we have 1, 0, 0, 1, 1. This is not 10,011. This is something completely different, and we're going to calculate what it is. Whereas the base 10 number system that we saw up here had each position in this number being able to be somewhere between 0 and 9. In a binary system, they can only be either 0 or 1. And in the base 10 system, you'd have each position to the left being 10 times larger than the previous position. So let's have a look at this base 2. Starting from the rightmost position, this is worth 1, exactly the same as we saw previously. But here's the kicker, that the next number is worth twice as much as the previous number. So the second position here is worth 2. And then it's 4, 8, and lastly 16 here. By applying the same logic that we did up here, we can calculate the value for this number. Let's start with 16 times 1 equals 16, plus 8 times 0, that is obviously 0. 4 times 0 equals 0, 2 times 1 equals 2, plus 1 times 1 equals 1. Then we end up with 19. So let's look at how we could use the NeoPixels to represent a binary number that in turn will represent time. I have 3 columns of NeoPixel strips, whereas this first column represents seconds, the second column represents minutes, and the last column represents hours. The bottom pixel represents 1, and then counting upwards, 1, 2, 4, 8, 16, 32. So let's take a time, for example. So say the clock showed this. How could we calculate the time? Just as we did before when we took the sum of all the ones, consider the lit pixels to be a 1 and the unlit pixels to be a 0. Starting at the hour, this is 2 and this is 4. So 2 plus 4 equals 6. For the minutes, we have 32 and 2. So that is 34. And lastly, for the seconds, we have 4 plus 1 equals 5. I'm going to pause the Python script, and then we'll try to calculate the time that is right now. This is the current time when I'm recording this video. So in terms of seconds, we have 16 plus 8 plus 2, and that is 26. In terms of minutes, we have 16 plus 8 plus 4 plus 2 plus 1, 31. Moving over to hours. Here we have 8 plus 4 plus 2 is 14. Took some time, but it looks about right. So for this project, you're going to be needing a few strips of NeoPixel and a Raspberry Pi. I used a piece of cardboard to glue the NeoPixel strips onto the cardboard to kind of lay them out the way I wanted them. As always, I hope you enjoyed the video. I hope you enjoyed seeing me build it, and I hope I managed to explain binary numbers in a way that maybe you picked up on what the idea is. And it kind of goes without saying, if you enjoyed, please subscribe to my channel, like the video, very important, and consider sharing. That would help. And I sure hope to see you next time, right? Bye.